All right, so this is the Unit 4 objectives overview. So this is summarizing all of the Unit 4 that we did, going right from the start to the end. And I'll stop and start this and see if I can have you do some of these also. So distinguish between a pure substance and a mixture by properties. Separation techniques, and then the composition of substances macroscopically, which is what you can see with your eye, and microscopically, which would be down at the atom level. So, properties, I'm going to go ahead and pause this. Go ahead and list what are properties of matter. Okay, properties of matter, you should have listed those that are here. Again, those are right in your notes, so you can refer to your notes. Separation techniques, what I'd like you to do is see if you can answer these questions. What is electrophoresis? What is filtration? And what is distillation? Go ahead and answer those questions and then check your answers. All right, the three separation techniques to focus on are electrophoresis, filtration, and distillation. Electrophoresis, we saw the video where they had water in a glass tube and electrical current was sent through it. There was a positive side and a negative side. And what that did is it pulled the water molecules apart and produced 2 volumes of hydrogen to 1 volume of oxygen. The next one was filtration. That would be like using a coffee filter to sift out large particles from a liquid. And then distillation, which we did in class as a demonstration, where we were separating out 2 different liquids using their boiling points to separate them. For the next one, I'll go ahead and draw a diagram and see if you can fill them in. All right, so go ahead and see if you can fill in examples of boxes for the mixtures and the pure substances that are listed. So do a homogeneous mixture, a heterogeneous mixture. In pure substances, do an element and do a compound. All right, so here we've got pictures of different types of elements, compounds, and mixtures. So for the homogeneous mixture, you should have drawn something that everything was evenly mixed, no matter where you slice it or where you pour from or where you take your sample, everything's the same. In a heterogeneous mix, you've got different sections of the substance are made of different materials. So in this one, I've drawn groups of red elements mixed with groups of blue elements mixed with green and mixed with yellow. So in different sections, this was the one that we said was kind of like a salad, where you've got tomatoes and lettuce and onions and things mixed together. Under pure substances, we have elements, which are one type of atom. So here I've got 2 different elements. I've got one that's a gas, and this one happens to be a diatomic gas because there are 2 of them. And then I've got an element with the red dots, and that would be a solid substance of one type of element. So when you see one type of particle and it's the same, then that is an element. When you see compounds, that's different, because notice that for these different compounds, here I've got 2 different gas molecules, and then I've got a larger gas molecule that is green and with the 4 black around it. Compounds are always going to be when you have different types of elements mixed together. So compounds have different types of elements combined together. Elements have one type of element together, or one type of atom mixed together. This next one, I think we pretty much, I'm going to draw some pictures of the different separation, the 3 different separation net techniques. So the first one I'll do is electrophoresis. And for electrophoresis, you've got a tube that contains water. And then you have two tubes that go off to the side. You've got a power source, so this becomes a positive charge side, and this side is a negatively charged side. And when you connect the power, it starts to pull apart the water molecules. Water would be in the central tube. The oxygen molecules are going to travel toward the positive side. So this will start to produce oxygen gas. And this side here, the hydrogen are going to be attracted to the negative side. So this will start to produce hydrogen gas that gets collected up into this tube. So it's literally pulling apart the water molecules, separating them out into hydrogen and oxygen. For filtration, this is where you've got a container to catch your liquid. You've got some kind of a strainer, and you're just going to pour your liquid with the particles you want to separate. Just pour the liquid right through there. That filter is going to catch any of the solid particles, and just your liquid will be separated out and passes through. For distillation, I'll draw this one over here. For distillation, what you have is you've got a flask, and you put a flame underneath it. Here's my flame. So you heat that. You've got a way to collect. Usually you do it with a column. Here's your liquid. You've got a column where the gases are going to travel up, a condenser that comes down, and then collects in another flask. So this is colder. So as the substance boils, the first substance with the lower boiling point is going to leave first. We'll say that this is, let's say we've got a mixture of a green liquid mixed with the yellow liquid. So let's say the green liquid has a lower boiling point, so it's going to be the first to boil. So I add heat, it's going to start to boil. The green molecules will become a gas, travel up into the glass column, and then because this is colder, as the gas particles move through here, they're going to start to condense and go through a phase change and become a liquid in your collection container. So by the time you're done, you'll be left with only the yellow liquid. The green liquid will have been completely removed. And at that point, you're going to stop the distillation, and you've got your two things separated. Next question is, cite evidence for the presence of compounded matter. And we know that substances are made of different types of elements because using electrophoresis, we can separate compounds into their elemental components. Describe the difference between elements and compounds. Elements are made of only one type of atom. Compounds are made of two or more different types of atoms. Next one is to state Avogadro's hypothesis and evidence that led to this hypothesis. You can go ahead and find that in your notes and write it down and then check it with mine. It may not be word for word, but see if you can find that in your notes. So Avogadro's idea was that equal volumes of gas at the same temperature and pressure contain equal numbers of particles. Next question says, use Avogadro's hypothesis along with combining volumes of gases to deduce the compositions of some compounds. So if I have gases that are combining and I have two volumes of oxygen combine with one volume of carbon, what would be the composition of the product and what would be the formula? The answer to this would be CO2. We have two volumes of oxygen to one volume of carbon. Try this next one. If I've got one volume of carbon combining with three volumes of hydrogen, what would be the formula? The correct formula would be CH3. So features of Dalton's atomic model. So the key points of Dalton's atomic theory were things that we just kind of take for granted now, but he's the one that came up with the idea and proved it. The first thing is all matter is made of atoms. The second idea he had is that all atoms of a given element are identical in mass and property. So all they're identical. Whoops, spelled identical wrong. And the third one is compounds are combinations of two or more different types of atoms. And the fourth one, which we haven't really talked about yet, is that a chemical reaction is a rearrangement of atoms. So those are the features of Dalton's model of the atom. So this is a good chance for you to grab your notes if you don't have them sitting next to you already, and to write down the law of definite proportion and the law of multiple proportion. So there's your law of definite proportions and law of multiple proportions. And the evidence for this in worksheet 3, we looked at hypothesis 1 and hypothesis 2, and we found hypothesis 2 was correct, where we assumed that not all atoms had the same amount of weight. Example of this, we found the ratio, and then we figured out how many times bigger one ratio was than the other compound that we were comparing it to. An example of this would be when we had a ratio of 1.33 for compound A. For compound B, we had a ratio between the elements that made up the compound as 2.66. B was 2 times larger than A. So B had 2 times more of one of the elements.